Hi, welcome to Provoke Your Physics channel. Today we are going to discuss about the torque experienced by an electric dipole when it is placed in an uniform electric field. Actually, it is a very important question, especially for the 12th standard. Even this also, okay, which is suitable to the both CBSE board and also the metric board. See, we know the electric dipole. I already told you in the previous questions. Like two equal and opposite charges separated by a small distance constitute an electric dipole. So when that electric dipole is placed in an electric field, what may happen? Let us see. See, let us take this is an uniform electric field. And for my convenient, the electric field will be acting in this direction. So this will be the electric field, and for my convenient, I am just taking this is a positive in nature. Positive in nature. So that is radially outward. Okay, positive electric field is usually radially outward. In which, suppose if I am placing an electric dipole, okay, once again, minus Q will be located here and plus Q will be located there. That is left side and right side. Okay, so and these two will be the distance between them will be 2a. And this O will be the center point. Okay, so now let us put the name for every point. Let us take this is A and this is B. Okay, now, so just think about it. When a positive charge will be located in an electric field, what may happen? Already in the previous question we discussed what is an electric field. Actually, what is an electric field? The force experienced by a charge. Similarly, even here, the charge will experience the force. Okay, so that force, I know that F is equal to, in terms of electric field, E into Q. So here, this will experience a negative force and this will experience a positive force. Remember, that's why I told you it is a positive electric field. So what will happen? This is negative in nature. Okay, already positive electric field is there. What may happen? Automatically there will be a force of attraction. According to the force of attraction, the F that is will be acting towards this direction. Similarly, okay, F will be acting towards this direction. Okay, so what may happen when the two equal and opposite forces are acting? Okay, according to the mechanics, it constitutes a couple. That is a moment of force. That is torque. So there is a rotating effect will be taken place. Okay, according to the rotating effect, we know that rotating effect torque is equal to, okay, R cross F, and especially it is a vector quantity. Dow vector is equal to R vector cross F vector. Okay, now I have to find what is this R. Usually this R is represented as a perpendicular distance. What is perpendicular distance? The distance which is perpendicular to the acting of the force. Now, see what is the perpendicular distance here? See, this is the force. This is the direction of the force. Okay, for this, okay, this is going to be the perpendicular distance. Similarly, this is the direction of the force. For this, this is the perpendicular distance. Okay, with respect to this point. With respect to this point. Okay, so this one is the perpendicular distance and this one is the perpendicular distance. By combining these two, I may have taken, okay, let us put this point C, okay, BC will be the perpendicular distance. Okay, so if it is right, okay, I am just writing, okay, tau vector is equal to BC vector cross, okay, that is F vector. What is a BC vector I can write? See, BC vector in terms of the triangle, okay, in the okay, this is tau vector. Okay, in the triangle ABC, okay, if I just want to know the value of BC, what is BC? This is right angle and this is theta. So this is adjacent side and this is opposite side. Okay, so if I want to write sine theta will be equal to BC divided by AB. Am I right? Okay, so BC can be taken as AB sine theta. What is AB? See, that is the difference, the distance between the two charge. That is, this is A and this is A. Okay. Now I can just write 2A sine theta. What is it? This is BC. Now I am going to substitute this value here. So tau will be equal to 2A sine theta into F. Now I have to write the F in terms of electric field. So I can simply write 2A sine theta into E into Q. Now look at 2A into Q. What is that? We have already known that is the dipole moment. That is P will be equal to 2A into Q. Okay. So when I'm substituting this value there, I will get tau is equal to, instead of 2A into Q, I can just write P. That is P E sine theta. Okay. This is in the value of magnitude. Suppose if I want to write this in the vector form, I can just write tau vector is equal to P vector cross E vector. Okay. So this is what the torque experienced by an electric dipole when it is placed in an electric field. Right. So the torque experienced by an electric dipole in an electric field is depend on the two value, that is P, that is dipole moment, E, the electric field, and what is another one? That is theta. What is an angle theta? That is the angle between the dipole with an electric field. Okay. So when we can have the sine theta will be maximum when theta is equal to 90 degree. When theta is equal to 90 degree, we may get tau is equal to PE. Similarly, when theta is equal to 0 degree, I know that sine 0 degree is 0. So tau is equal to 0. So from this, we come to know that when the dipole is placed in an electric field, it experiences a torque. And especially when the angle between them is 90 degree, it can have a maximum torque. That what is the condition? So in that case, the dipole will be, okay, the dipole will be perpendicular to the alignment of the electric field. So suppose if it is an electric field, this is a minus Q and this is plus Q. What will happen? This will rotate and align along the direction of the electric field. Suppose if I am keeping the dipole, along the direction of the electric field, nothing will be happening. Nothing will be happening. Why? Because here theta is equal to 0 degree. Okay. When theta is equal to 0 degree, tau is equal to 0. When theta is equal to 90 degree, tau is maximum. See, the torque of an electric dipole in an electric field can be explained with the help of these two. See, this is normal polythene paper. This is plastic comb. Okay. Now first I will rub it. In order to rub it, okay, I am just generating a frictional electricity. Okay, due to the frictional electricity, there will be a transfer of electron and the proton will be taken place here. Okay, so now I am not going to do anything special. Okay, I am just keeping this comb near the paper, small pieces of paper. Now let us see what will happen. See, when the pieces of paper were attracted by the comb, you could see one thing. Okay, the pieces of paper will be rolled down. Why it is being rolled down? Because of the torque experienced by the paper. Okay, so when I rub the comb, it is generating an electric field. So here it is an ununiform electric field. But in our case, we were discussing about the uniform electric field. So you could notice one more thing. Along with the rotation, the paper will be moving forward. Why? Because of non-uniform electric field. So when the dipole is placing in a non-uniform electric field, along with the torque, it has some translational motion also. What is a translational motion? It is a linear motion. So along with the rotation, it will be moving little forward. Thank you. Clear? I hope you understand. Thank you for watching. If you like this video, please like, subscribe and share. Thank you.